Mhm. Okay guys, so we will start today, and let me just give you a brief about this project, what we are planning to do here. So we do have a data set called Airbnb. Okay, it's actually simple data sets. We have three fields here. Okay, and this is in raw format as of now. And what we are going to do in this, we will be using AWS Glue. Okay, for doing some transformation. Okay, it's transformations. I'm not covering too many transformations. Okay, I don't want to do, but like I'm not planning you to show you how to replace some characters, how to make it uppercase, or do substrings and all those. My main objective is in the front project, because those all those syntaxes we have actually already seen in the Glue notebook and in the PySpark demos, so you can adapt from those if you require in the future. But in this here, I am looking more on the concepts wise. So yeah, so what we are going to do, a little actually simple transformation I'm making here. Then what we are doing, we are actually connecting our glue job with first of all we are connecting it with Redshift for query execution. Okay, we will perform SCD type 2. That means we will look for the new records in the source, new records, edit records, those kind of features we will see. Okay, and we will see what happens here. Like maybe on day one we will be doing some load here. Okay, on day one we will be doing some load here, and using the AWS Glue after checking for SCD2 and all those things, it will be coming inside. Like first of all we will save it on S3 in Parquet. Okay, and then we will move it to Redshift. This is going to be our final target. So this is my source, and this is my ETL, and this is my final target. Okay, but what happens, like if on day two we get some records. Okay, let's say if we day two we get some updated source, like we might have some new columns in the records, we might have some deleted columns from the source. So all those things we will check and verify here in the ETL in the SCD type 2. We will discuss what are the SCDs and what is the type 2 of those. Okay, some extra things that we will be doing, we will be maintaining some logs in the DynamoDB. We will be maintaining job logs in DynamoDB. We will be sending emails using SNS, and yeah, that's all actually we are doing in this project. Okay, we are looking for SCD2s, how to configure this, and we will, like in this SCD2 part we will see quite a few things. We will see some ETL operations, log, how to connect DynamoDB, how to execute Redshift, how to connect and execute queries for Redshift tables, and how to send emails, and DynamoDB logs also we will maintain here. So this is going to be an outline of this project. Okay, this is actually also called data pipelines in the real time. Okay, so mostly the source is actually mostly the S3 only, mostly in the CSV format. Okay, and then we have ETL operations using AWS Glue. Intermediate target you can say as S3 again, and then we have a final target as a Redshift tables. So data travels from source to target, and here in the Redshift, data is ready for the analysis. Data is actually ready for the analysis, and you can connect this data with your BI tools, with your machine learning tools, and such that you can use it. and this actually helps organizations, making some decisions for the future growth. So yeah, this is the context of the project, and if you have any questions here, please let me know.
No question.
Okay, so then let's see. Let's say starts with some codes here. Okay. So actually, I do have the complete code here. Let me actually close all these windows. Just a second. Okay, actually this code says day one, but this is actually the complete code. Okay, because I tried in earlier pages like separating the code in day one, day two, and day three. But it was actually becoming a bit confusing. So I have now kept it in a single file, and we will explore it line by line. So yes, now here you see that we do have few more extra imported libraries. So this is something you will get to know when you are coding and some logic, and when you see this is like, I'll say do not try to memorize these things. Okay, I will say do not try to memorize these things. That what all you have to actually import from where. Okay, don't try to memorize these things. So for example, let's say you are looking to use monotonically increasing ID in your code, and if you don't import it from the SQL functions, it will actually fail for you. But let's say you want to import this, and if it fails and it says could not find monotonically increasing ID, all you have to do is just go on internet and or just search for it, how to import this, and you will get this from statement. Same goes for date time, same goes for SQL context, for window functions, for types, or actually, so if you like whenever as in when you think that you need to import something, okay, at that moment only you see how to import that, and you will actually learn that. And few things, as I'll say, do not get confused here, that I am saying from PySpark.sql import functions as functions. This means I am importing all of the functions of PySpark SQL. And same thing, if like this line number 12, line number 15 is actually same. And same I'm actually doing here on line number 14. It's actually not important, or you can say it's not mandatory. Like once I do line number 15, when I have imported star, that means all the functions if I have imported, there's no need to import monotonically increasing ID separately. But I was just looking to showcase to you that how we can import individual things, or how we can import the all of the things. So this is the import things, and I will discuss as and when you need to import something. And then simples of my one line is there. All that I'm doing is I'm just capturing the current timestamp from the system using the datetime.now and converting into a string format. Then rest everything is actually same. This we have already seen in the Spark Shell demo, that how we create glue contacts, Spark contacts, and job configurations here in the AWS glue job. Okay, then so you can say this is something that we have already seen, and some of the libraries that I am using here, I will be introducing it to you where as and when we see its use case. Okay, so now let's come down. Okay, so this is my input path. That means here I have saved my file. Okay, and from this location I will be getting my input data. Let me actually show you the data also. I hope that you might have seen this, but yeah, again, let's just see it once more. Airbnb price. This is the actually data set, and obviously I'm going to modify a little bit for explaining it better. Okay. Maybe let me just make this modification right here. And yeah, it looks good. We will be using this Airbnb price CSV for our day one load. Okay. Yeah, and this is the location I am storing my AISA input path. This is going to be my, like, these variables are actually very pretty much obvious. This is going to be my output path. Okay. Now, two things. Uh, we need to compare this data on day 2. Okay, we need to compare this data on day 2, and for that, actually there's nothing like that. You can directly read the data from Redshift and get the data into a data frame or maybe a SQL table. That is actually not possible, at least now. Okay. So what we guys do, we guys unload the data of current Redshift table. Okay, we guys unload the data of Redshift table, and then we are going to make this comparison here. Okay, then we are going to make this comparison here, like from like what I'm saying right now. And don't worry, I am going to repeat this one tomorrow also. What I'm saying right now, before loading the data into our Redshift table, we have to unload the data from Redshift table, compare that data with the source table, look for the updates, delete, addition of the records, do all the processing, merge it, and load the second day data on Redshift, and repeat the same process on day 3, day 4, day 5, like this. Like every day, this process will be repeated. Okay. Then I have file path variable and bucket variable. I'll let you know why I have kept these two separate variables here. And then I have IAM role. Okay, this also I will let you know, but yeah, if I just give you some idea, if you remember in the Redshift copy commands, we need a IAM role. This is the same IAM role. So when I'm going to execute my commands, that is going to be copy command from my AWS glue job, this is the exact role that I'm going to use, and this is the role which has the permission to execute a script on Redshift uh, Redshift table or Redshift clusters. Okay, these are my some input variables, you can say. Then first thing first, I am reading my source file. Okay, this is my S3 input path. If you see, this is the glue dynamic frame options. This we have actually already seen. And I'm simply reading like my connection type. I'm saying it's S3, like my I'm trying to connect with S3. My path is this path, S3 input path. My format of the current file is a CSV format. This is my source file, and it is there in the CSV format. And its few options are like it is separated by comma, quote character is double quote, and with header true means that my file is having first line as a header. Okay, this is my code for reading the file. Then basically what we are doing here, this is actually a bit interesting thing. So as I am telling you that we are connecting with Redshift, so at this place exactly where we are connecting with the Redshift part. Okay, so we have this Airbnb price details table created on the Redshift. So first of all, I have defined, see, all these three things, line number 49, line number 50, and line number 51 are just variables. Okay, do not get confused that these are some programs or command or something like that. No, these are just variables, nothing else. Okay, and variables of the string type. Okay, these are just string type variables, and we are holding some string inside those. So my first variable is table name, that is having my table name defined here. My second variable is SQL query. So like when we do unload now, when we do unload, we can actually define that what exactly we want to unload from the table. Okay, so like if you see right now, I'm saying select star from, and my first replacement is actually table name. That means I am going to say select star from table name here. Okay, that means whatever the data in the Airbnb price details we are having, I'm going to simply unload that. Okay, and that unload, this is, or you can say this is the query for the unload. This is not the complete query. This is the data extraction query for the unload that I'm creating here, not executing, just creating a query variable. Then next thing that I am doing, I am saying unload. Then uh, my first variable is here is that I'm replacing here in the curly braces is SQL query. Okay, this means my command will something look like this, that unload, and it will say this select star from this Airbnb price details. Okay, it will say something like that. Then it will say to where we want to unload. Then my second variable here is unload path. That means this is the location on line number 38. This is the place I want to unload my data. Then I am saying my unload output type should be a Parquet, not a CSV or something like that. And I'm also saying clean path parallel. This means I'm cleaning the path. Okay, I'm cleaning the path before. I mean, let's say I have unloaded data on day 2, and I do have some data unloaded here at this location. So before unloading it next time, I'm simply deleting the data from this location. That's what clean path does. Parallel execution, I have turned it off. Okay. Then I am defining my IAM role. IAM role, as you see, we define in the copy command. Same way we also define IAM role in the unload command. And then I'm passing my IAM role ARN variable. So this is my IAM role location. So this is how I am going to create SQL unload query. Again, reminding you, this is simply a SQL unload query. Nothing has been executed here. Okay, this is just a variable. SQL unload is just a variable. As you can see, it says in bracket variable and it says literal string. That means it's just a string type variable where we have defined the query that we are planning to execute on our Redshift cluster. Okay, so line number 36 to 51. Look at this code. If you have any questions, issues, do let me know. Do not worry if you don't get it. We are going to execute it on. Obviously, we are going to execute this. So yeah, if you have any questions, do let me know.
Yeah, so that's just few points. We are using input path, output path, and unload path, right?
Mm-hmm.
So input path, everything is in S3. So here we are taking the data from where? From input path, right?
Yes.
We already preloaded.
See, what happens mostly in the real time, if I tell you the real time scenario, most of the times your data source is always going to be S3.
Right.
Reason for this is because S3 is cheaper. You can store more data on S3 on a cheaper cost. So that's why our project does look to save the data on maybe on RDS engines or maybe on databases, because see, data is same. Okay, you are not going to query the data anyhow. You are going to query the Redshift data for your analytical purpose. Then what is the point of saving the data on your databases? You save the data on S3 only. Yes,
Right.
some might be there might be some specific cases in the time that you might have data on maybe some databases, maybe on some web servers. So that is a different scenarios. But even from the web servers, they look to push the code, push the data onto S3s only.
Okay. So my question is, here we are moving the data from input path to output path, right? That folder, output Airbnb, using the glue. And this unload path, I did not get understand is what is this unloading the data from the Airbnb previous, and it is where it is going from Airbnb previous.
Okay, see. So let me actually open the notepad. Please. Let's say on day 1, okay, on day 1, we have some data in source. Okay, let's say we have some data in source, and like just a second. F1 is going to be, we have some data in source. Okay, step will be that we process this data with AWS glue and copy in Redshift. This is my day one process. That means, see, what I'm saying. Let's get a context of day one also.
Okay.
So let's say from tomorrow onwards, we are planning to build a new KPI in our dashboard, and for that we will be getting data from some source. Okay. Let's say from tomorrow onwards, we are going to get some data in our source, that means S3, and we will be showing that data in some KPIs format on Power BI. Let's say Power BI. Okay.
Okay.
So on day one, that means tomorrow, we will simply read all the data. We will do its transformation, and then we are going to copy that data into a Redshift clusters.
Okay.
Now let's say on day two. What's on day two? Let's say we get some. Okay, let's say on day one we had around like maybe in source we had around 1,000 records. Okay.
Okay.
On day two, let's say we get step one, data in source. Now we have like let's say some 200 records, but here we have 100 new records. Like whatever we loaded on day one, let's say from that data, some records are actually modified on today. So let's say we have some 200 updated records.
Okay.
Okay, and let's say some 50 records are those which got deleted. Like 50 other records which got deleted from the source. Now my step two is actually we want to load this data. Okay, step two is load data in Redshift with glue. But what happens here? How will you identify which are the new records?
Okay.
How will you identify which are the updated records or deleted records? Like this, I have told you, they got deleted, updated, or modified, but your code does not know that part, na? Your
Right.
AWS glue does not know. So it needs to make a comparison. That it needs to make a comparison. Like it will be like what is status of data in Redshift, okay, versus what I have in source. This is going to be comparison, okay, that what we have in Redshift already and what I got in source. Okay.
Okay.
So to make this comparison, we need to have this Redshift data also in data frames. Okay. So what we do, we unload this Redshift data. Okay. We day one Redshift on S3. Okay. Then we read this data in data frame. So now we have two data frames, df of day one, okay, versus df of current source.
Okay.
Now, if I compare these two data frames, I will be able to make the decision. What are my new records, updated records, or deleted records? A bit clear now?
And for day three, the new data which will be coming versus the day two data, because the day two data is having a all the record from day one also.
Exactly. So it's like continuous process. You will follow on consecutive days.
Okay, and one more question from the source side. Suppose in a particular bucket, this in day one, 1,000 record has came. So the day two record will override the data, or it would create a different folder inside the same bucket.
See, that is something you can define in your coding as per your requirement, and this is the types of SCDs. So actually, this is actually the good time to understand the types or discuss the type of SCDs also. So, do you guys know SCDs, slowly changing dimensions?
Right.
Yeah.
So exactly the same question you asked about slowly changing dimensions, like which type you want to perform. You want to perform SCD1, that means you want to override the records. Okay. Do you simply just want to override the records, or you want to perform SCD2, where we simply just go ahead and keep the history of the records, like what is something maybe such like, okay, where is that sheet? I have saved it or not? I think I not saved it. Okay, just a second now. So I am just going to take a few records from here, maybe 20 records are fine. Okay, so what happens in SCD1? Let's say we have got these 15 records. Let's say we upload these 15 records. Okay, let's say we upload these 15 records on our Redshift like this. Okay, this is my day one load. Okay, and then let's say this is my day one load. Okay, and I'm just going to make it in center, and then I get these many records on day two. Now here, if I talk, let's say this is my listing ID. Let's take few records from here. Let's say these two records. Okay, and if I place it here, and if I do merge and center. So this is like bit more clear now that we have these day one records, and these are my day two records. Okay, out of which these two records, if I talk, is repeated records on day two. Okay, if I just take a red color for these, and let's say host name change from Doti to, I mean, oh, what a name. Let's say Shally or something. Anything. I mean, Adam could be Adam, and Charity could be Adam only. Okay. Let's say these two records got updated. Like, mean this primary IDs are same, but record got changed. So what effect will be happening in the final redshift table? Okay, this is my final redshift table, and this we actually are discussing the SCD1 right now. So on day two, obviously these are the new records. We will identify those, okay, and we will simply append these records here like that. That's all. What will happen to these two records, like 7322, 7322? It will actually take this record SCD1, and we will override this record here. Okay. Same way we will take this record, and we will overwrite it here on our Redshift target. And definitely we will be handling this by coding. So this is my SCD type 1, where I keep my Redshift table updated with the source tables. Okay. And I do not create duplicate entries in my table. I simply overwrite my records in the table. That's all I do here. Okay. This is SCD1, but if I just change a few things here, that means if I just do undo twice. In SCD2, what actually we do, we actually create few more columns in the Redshift, and we also maintain the history. So let's say what I will do, I will have some created date here. I will have created date here. Now from this point, remember we are going to discuss SCD2. SCD1 means overwriting the data on our final target table. Then we will have updated date here, and we are going to have a active indicator. Okay. Now what will happen in the SCD2? On day one, we will have these records. Okay, on day one, we will have these records, and they will get placed here. Okay, we will have them placed here. Okay, till here. I will have some new records. And actually, let's do one thing. Let's delete this record. Let me just, let's say. Okay, this means deleted. Okay, let's say this record got deleted on day 2. Like, when the source file came on day 2, we could not find this record of Jane there. Okay, so what going to happen now? First of all, we are going to identify the deleted records, and whenever I see 7097 in here, like this one, this record actually going to get modified with the light green color, and just actually highlighting it. And okay, I actually missed it here. Let's go step by step. On day one, we load all these records. We will get a create date applied here. Okay, we will get a create date applied here. Actually, it's end date, not updated date. Okay, so we will have a create date applied here. Let's say these records got modified on 12th of June. So on 12th June, these are the records that I got updated. Sorry, got created. Okay, on day one, I just loaded all these records, whatever I had in my source, all those records got loaded here. Okay. Those records got loaded here, and we applied the create date. End date is going to be indefinite, so it's like active record, so it's going to be indefinite, something like this. Okay, an active indicator we will update for this record as Y. So I will have these many records. So this is going to be the status of my table on day 1. Okay, this is going to be the status of my table on day 1. But let's say on day 2, this record Jane gets deleted from the source. So what we will do here, we will mark this record deleted. Okay, and how we are going to mark this record deleted? We will apply, first of all, we will apply a end date here. So my end date is actually obviously going to be the next day date, 30th of June. On 13th of June, this record got end date. Okay, it was deleted, and my active indicator will become N from Y. That means this record is now not active in the source. This is one thing with the deleted record. Then 2 records we have updated here. So what will happen happen to these 2 records? Let me just copy these 2 records. We will make new entries for those records in our Redshift table, and those entries will have the create date as 13th. Okay, and their end date is going to be 999 only. Like, this is my updated records, which are active indicator with Y, and these two like still they have like same listing ID. Okay, so what will happen here? Here we will apply end date. Okay, so end date will be this thing, my end date, and this YY will become N actually. This is going to be a status of my, on obviously for the new records that we got on day 2, it's going to be 13/06/2023 and 999 for all those things. Why? Like records which are new records are simply just going to get the new create date and the end date. There's no comparison is going to be happen. So this is how I update my table in SCD2. This is what we are going to perform in this here. So in SCD2 we maintain history also. So I do have these records here also and here also. Okay, but here my this activity record column is actually indicating that this is the latest detail. Now now Doti has been changed to maybe Dolly, something like anything, any name. Okay, okay, and Adam and Charity has become let's say Adam only. So this is my updated record. So this is what happens in here. Actually, it should be this thing only. So do not get confused. It should be these two names actually. This is the final status. Okay, this is the exact final status. This is SCD type 2. Now to make this comparison, which are the deleted records, updated records, we need to have this Redshift data also loaded into our data frame. So what we will do once we start processing on day 2, first we will unload this data, get this data into data frame, and then we make comparisons. And also we assign a surrogate key here. Okay, surrogate key is nothing but just a sequential number to your records. That's it. So something like this 1, 2, 3. Okay, something like this you will get in your final table. So yes, if you have any questions here.
No questions, sir.
Okay.
No
So
question.
I hope that you got SCD1 and SCD2 difference, first thing. And second thing, to your question, Varsa, it completely depends. Maybe you can create date partitions, you can overwrite the data in same path, or you can create date partitions, or maybe you can use SCD type 1, type 2, type 3. That is depending on your requirement. So there's no hard or fixed answer for that.
Okay.
Okay, but I hope we got what we are actually trying to do in our coding process. Okay, so see, next thing that I am doing here, like this is like my data reading only. Okay, and this is I'm planning to, if you see this, I am saying let's start from the table. I am planning to load all of my data from the current Redshift table to my some S3 location, so I can read the data into a dynamic a data frame. And after that, let me actually just open this my functions. I'm saying call unload data Redshift. Okay, I'm saying call unload data Redshift, and I'm saying I'm passing my query, whatever I have created. I'm passing that query. I'm passing that query in a variable. Okay, but if you see, I'm also saying my functions dot. Okay, this means the definition of this Redshift unloaded a Redshift function. This is a Python function, is defined inside a file called my functions. Okay, and if you see here, I am importing my function. This means import my functions. If you have my functions created, okay, this is nothing but a file name. You can also call this anything, like any name you can give to this file, and then just import it and refer to the import name, and refer to the functions. That's all we have to do. Something like this. My functions, this is what I imported and use unloaded a Redshift. So code actually will come here on my functions now. Okay, and this is the file where this is, you can say this is the code location where I have actually defined all of my logics for my functions that I want to use repeatedly. This means if I change, okay, this means if I change my input location, my output location, and my unload path, I can use the same code for all of my data sources, all of my files. Okay, I no need to write my Redshift logics and all of those logics again. Like whatever you can identify that you can convert into functions and use it again and again, you should get that into functions and store them in a separate file. Okay, so why I stored that in a separate file? So I mean, I could also say that I have the definition. I can simply copy paste that in here in this code itself, but that is going to make your code unnecessarily lengthy, a bit more difficult to read, and still we have to copy paste. I mean, we can make some mistakes here. Okay, like if you see, my current file is around 200 lines of code. I mean, we do have some spaces here, but yeah, you can see around 200 lines of code I have here. But if I do not create the functions separately, then my code will become like 400 lines of code, because I also have 200 lines of code here. So instead of making large files of code, we try to divide the code into separate small files, or whatever we can, like, that however we can separate these things, like keeping the functions in a different file. That is the motive here. So I am having my unloaded Redshift. Okay, I'm just going to copy this and find it here in this location. And see, its definition says it receives one variable. That variable I am passing from this SQL unload. Okay, it's actually same variable. I can what will happen? SQL unload will become SQL query here. That's all it's going to happen here. So you can say whatever I'm passing here, whatever the first variable I'm passing here, it will receive the value in here in SQL query. Okay, once I receive my SQL query, I'm going to get that. First of all, I'm going to create my Redshift client, like we create clients in Lambda functions for our S3 recognition, tax tract, Lambda clients, IAM clients. The same way we have created a Redshift client, and this is known as Redshift-data. Okay, then I need to pass some credentials to connect with my Redshift. Okay, those credentials are cluster ID. It is Redshift cluster 1. This is the name of the cluster that we get while we create the cluster. DB name is dev and Redshift username is AWS user. So these are the details that you will get when you create the clusters for yourself. Okay, then basically I am saying using the Redshift client, RS client here, execute the statement. Okay, execute statement is a function, or you can say is the API inside my RS client library, that whatever the query we are going to pass, it's going to execute it on the cluster which location I am passing it to you. Okay, again repeating the same statement. Execute statement is the API that is going to take a query from you. Okay, that query we have actually designed in the variable called SQL unload, and then we have passed it into a SQL query called variable on line number 50 into this code, this place. Okay, then we need to pass some credentials to connect with Redshift, and whatever the cluster credentials we pass on that cluster, this execute statement is going to execute the query. So understand it here. So it is exactly the same process that we go on Redshift cluster, open the query editor and fire a unload command there, or maybe fire a select command there, or fire a or like any command that I can fire from my SQL query editor that we have seen in the Redshift or demos. It is the same process, but this time, instead of doing that process manually, that instead of a human doing the process, my code is doing that process for me, and it is going to authenticate with the cluster and going to execute my query. Okay, like if you see, I am passing my database as my DB name I am passing here. Then I'm passing my cluster identifier as a cluster ID. I'm passing my DB user as a RS user. So these three variables I required, I have got here. And then finally, I need to pass SQL. That means what is the query that you want to run? And I'm passing my SQL query. Again, remember this SQL query is actually getting the details from this SQL unload here. Okay. If you want to avoid a confusion, whatever you can do, what you can do, you name the variable SQL unload here also. Even you can convert this variable from SQL query to SQL unload. So any name you can give here, that's open to you. Okay. So in this statement, I am executing my query, and remember my query is going to start executing on the Redshift cluster, not on AWS Glue. Okay. My query, again I'm repeating, is going to start on Redshift cluster, not on AWS Glue. Okay. After that, once what is going to do this execute statement, it's going to give me a response, and that response will have the ID, the query ID it will create. Okay. If you see here, my response will have a query ID. Using the same ID, I just see from the response, I'm just taking the ID only and calling it QID, and I am creating a infinite loop using while. Okay, why I am doing this? First of all, because as I said just a few minutes back, that the query line number 59 is not going to execute on AWS Glue. Understand this part. We are delegating a SQL query, a Redshift SQL query to Redshift server, and it's going to execute there. Okay, and if I do not write this while loop, my function will be over, and my Python code will start moving ahead with its code or its execution. That means my Python code will come here and it will try to read the data from this unload data location. But what is happening here? The query has been started running on Redshift. It might take 5 minutes, 10 minutes, 15 minutes. But if I do not have a while loop here, my Python code will start executing from the next second only. Okay. So to avoid this confusion, I'm applying a while loop. So unless my Redshift query is finished on the cluster, my code is going to run a loop, and it's going to check the status of my query, whether it's completed or not. Okay, so for that purpose, I took the ID of the query from the response, and I'm while not done actually means, like, see, done is actually coded false here, and while not done, it's always going to this is actually always going to run the loop infinitely. Okay, but I am saying using the Redshift client that I have created here on line number 52, describe statement gives the status of the query. Okay, describe statement is going to give you the status of the query. I am passing my query ID here in the ID part, and from the describe status, okay, like, see, this line here on line number 64 is going to give me the status in a dictionary format. Okay, in a dictionary format to this variable called description. I am calling it DAC as a description, and from this description I am going to get the status into a status variable. Okay, I'm going to get the status from this description status as a status variable, and then I say if the status is equals to failed. Okay, if the status is equals to failed, then I'm going to print that the status of the particular query ID is this. That means query ID I'm going to print, and I'm going to print the status. It is failed. I am going to raise the exception. That means my code is failed. I'm going to raise this exception on the logs and break out of this while loop. Break statement, if you don't know, the meaning of break statement is break the loop and come out of the loop. Whatever the loop condition is, don't care about that. Okay, because loop condition is always satisfied. It's going to run in an infinite loop, long loop. But whenever the break is done, okay, whenever I say break, that means come out of the loop. Okay, so see, uh, if it is failed, I will get this message that my query has been failed. Then if my query is finished, I will say query is completed and again break the leg. See, anyhow, what's my motive here is till the time my status is not failed or finished, that means it is running. Till the time my status is running, I will not come inside any of this if condition and I will not hit this break keyword. Okay, until unless I satisfied conditions with a failed or finished any one of this, I'm not going to hit my break keyword, and until unless I hit my break keyword, my status is going to running, and while loop is going to run until unless my query is finished on the Redshift cluster. So the control of my Python program or my AWS Glue program will stay here only in this function. It will not go outside of this and start executing the next statements. Okay, so this is what going to happen. Once my query is finished, whether it's failed or finished, I will get that status printed on my AWS CloudWatch logs. So go through this function. It is a bit new thing for you. Okay, go through this function and let me know if you have any questions.
I just wanted to understand how this parameter are getting passed, that input location, output location dynamically.
I am not passing it dynamically right now. As you can see, it's hard coded. These parameters you are saying. These parameters you are saying.
Yes. So in my function, there is one more function where this.
See, that is a different function. Don't look at this. That will have its own definition, its own thing. So just focus on this one, 50 to 73 right now. Don't try to skip it. Okay, just 50 to 73.
This I got it. Like we are just creating a. There is already a cluster ID 53, and we are trying to make a select query, and we are checking whether that particular select query is success. Then in that case, uh, success or fail. Based on that, we are making a if else statement using break. So this part I understood.
Okay, then this is all Varsha for now. If you understood, it's all good. Just hold here. Okay.
Okay.
So yeah, Rama, you have any questions?
No questions, Jalis.
Okay, so see, what we will do tomorrow. Okay, it's already 10 actually. I will keep my Redshift cluster on. First, I am going to show you the code execution of the code till here, till this function. Okay, I am going to show you the code execution till here. So we will see its output and we will, we'll be in more confidence that how it is actually working. So like today we have just seen it theoretically. Tomorrow I'm going to execute this function for you. Then we are actually going to start from this loop, this code. Like we are going to start wherever we have left in this code. So basically, actually, if I just finish it, if you just allow me 2 minutes more. So what we are doing here is like once my function will be complete, like once my unloaded redshift, that means this unloaded redshift is completed with a finished or failed. If it is finished, obviously, in that case only, my code is going to trigger this line number 55 only in the case of finished, because in the failed I have already raised the exception. That means termination of my glue job. Okay, that means termination of my glue job. So in case of finished only, in case of success only, we are going to execute this line number 55, reading the unloaded data into a data frame. If I be specific, this is we are reading in the dynamic frame. Okay, then I do two simple things. I convert my data source, this one data source, and I call it source data frame. That means I'm converting my dynamic frame to Spark data frame, and data source one, my unloaded data, I'm converting it to and calling it previous data frame. Okay, so both the dynamic frames I'm converting into a Spark data frame. Okay, this is what I'm doing. Okay, here. Till here, we have learned this code theoretically. First, we will execute this code practically. Then we are going to move ahead with our more logics and explanations. So yes, if you have any questions, otherwise we will just wrap up for the day. And what I can do for you, just in case if you try to hit your head, I'm just going to share this code with you. So what do you guys, if you have some free time, if you just look into these codes, you can just try it out and see these codes. If you can understand them by yourself, that is great. If not, no issues. We are going to look into this code for next 2-3 days.
Sure.
Okay. So yeah, that's all for the day.